So hi all, in this video we'll be talking about interfaces. This video is a series of videos that are related to the OOPS refresher module. So if you want to revise any of the previous topics, you can see the earlier videos, but other than that, in this video we'll be talking about interfaces. So interfaces define contracts that classes must follow. So interfaces just they define contracts and they should be followed by the classes. So we'll see all of them with an example, right? So they specify what methods a class must implement without specifying how they should be implemented, right? So this means they only give the structure, right? So they don't say about how that method should be implemented, but they only give the structure, right? And the next thing is this allows for polymorphism and loose coupling. So we'll see all of these with an example. So what are interfaces? A interface is a contract that specifies what methods a class must implement. It defines the what but not the how, right? So we saw the same earlier. So we'll come back to this why to use interfaces, etc. But for now, let's take a look at this interfaces and how do we define those interfaces in Python. So Python does not have any explicit interface like Java, but they use abstract classes and then they use protocols and then they use these abstract classes along with the abstract method. So let's understand this with an example. So if you see here's an example. So we are importing abstract classes ABC and abstract method, right? And then you have a class defined called as payment processor and it is extending from the abstract class, right? ABC. Now there are two methods, right? Abstract method. There are two abstract methods. The first one is the process payment and second one is the refund. So if you see, we just defined that there should be a method called as process payment, there should be a method called as refund, but we did not implement it, right? So this is what we are saying, right? So if you go back to the definition, it says it defines the what but not the how. So it is saying the class payment processor has two abstract methods, and the abstract methods are process payment and then the second abstract method is the refund. And as usual you have a validate amount method on the same class. So now whoever is implementing this payment processor, in this example if you see, credit card processor is extending this payment processor that we defined above. So whoever is extending this, they have to implement, right? So they have to write the implementation, right? So if you see here, we have the process payment implemented and then we also have a refund implemented, right? The same thing goes for PayPal processor, right? Because it is also extending from the same payment processor, right? So it also has to implement the same methods here. So if you see, this is how we are making use of an abstract method. So we have a structure. It says that anyone implementing the payment processor have to use this following structure. So we define the contract and whatever the classes that are implementing this, they have to define that. So now if we go to the usage, there is a credit card, right? So we are creating an instance of a credit card processor and then we are also creating an instance of a PayPal processor. So now here if you see, there is another method called as checkout. So checkout takes a processor which is of type payment processor, right? And then it says processor dot process payment. Now if you see here, how are we making use of polymorphism is, because this processor is of type payment processor, we can either pass credit card processor or we can either pass PayPal processor, right? Why? Because both of them, if you see, both the PayPal processor and the credit card processor, both of them are extending from the payment processor, right? So for sure they must have implemented the methods which are there in the payment processor, right? So we can use either the credit card processor or the PayPal processor in place of a payment processor. So you can call checkout credit card 100, that means it will use the credit card processor. If you call checkout PayPal of 100, that means the PayPal processor. So this is the output. Now if you see the same example in Java, let's switch to Java. So here you will be clearly mentioning that this is an interface payment processor. So same thing goes. So these two are abstract methods, right? And then these two are the generic methods. Now if you are implementing the payment processor, in this case credit card processor is implementing the payment processor, right? So it has to implement, it has to define the process payment and the refund. And if you see here, we are making use of override, right? So that means these methods override whatever is there in the parent class. So we saw the behavior of override in the previous video. So if you want to go in depth, you can watch that video. Okay, same thing goes for PayPal processor too, and the rest is exactly same. So you create a payment processor of credit card, you create a payment processor type of PayPal, and then you can call this checkout method, right? So moving on to multiple interface implementation. So now let's see what is this multiple interface implementation. So classes can implement multiple interfaces. So let's say if you have two interfaces defined, right? So in this case, you have a flyable class, you have a swimmable class. So both of them are abstract classes, right? So how? Because they are extending from ABC, right? And then they also have abstract method, right? So here you have a class duck which is implementing both classes, right? So it is making use of multiple interfaces. The first thing is a flyable and the second thing is a swimmable, right? So because it is implementing both the classes, it has to implement these methods too. So that is why you have fly, that is why you have swim, and then this is its own method that is defined on the class duck, right? So if you see, we create an instance of a duck class here, and then you can call duck.fly, duck.swim, and duck.quack. So if you see the same example in another language, let's say Java. So similarly, you have two interfaces, right? And then this duck class implements both these flyable and swimmable, right? So because if it is implementing both these classes, it has to define both these functions. So it will go ahead and define the logic for both these functions, and then we annotate with override because we are overriding the method which is there in the parent class, right? Same thing, and the rest of it is the same. We create a new instance of a duck, and then duck.fly, duck.swim, and duck.quack. So now let's see a real world system, that is a notification system, right? So if you see here, as usual, from ABC we are importing the abstract class and then abstract method. We have a class called as notification service. This is extending from the ABC, and then there are two abstract methods defined here, send and can send. So whoever is implementing this, right, has to define these methods there. So email service extends notification service, and then it should implement them. So it is implementing the send and then can send. Same for SMS service, it is also extending this notification abstract class, so it should also define these two methods, right? If you see the logic, it's just simple. It says sending email to recipient, and then this SMS thing says sending SMS to recipient, and the only thing is in can send of email service, it checks if there is at the rate, right? So email should have an at the rate, right? And same thing is for SMS service, it checks if the recipient starts with the plus. So now you have a notification manager class defined here, right? So in the init method, you have something called as services. This is a list of notification service. So if you see, this is our main class, right? Abstract class notification service. So we are taking a list of notification service. Why? Because we can use SMS service or email service, right? So we can interchangeably use these services whenever we require. So you have a method called as add service. So what it does is, given a notification service, it adds to the list of services. So self.services.append service, and when you call broadcast, what it does is, for each of the services that you added earlier, it just calls, it checks if service dot get can send, it just checks if service dot can send is valid. If it is valid, then it will just send the message. right? It will call a send method. It is defined on each of these classes, right? So this one and this method. So usage is you create a notification manager, right? And then manager dot add service, you will add the email service, you will add the SMS service, and then when you call broadcast it, you will get this output. So see the use of interfaces. You define the rules or the interface or the contracts in your interface, and then whatever the classes that are implementing or making use of these abstract classes, they will have the concrete implementation. So with that, what you can do is you can use these classes interchangeably. See about polymorphism in greater detail, but you can use these classes interchangeably. So this is a small representation interface payment processor. Both these processors are implementing this payment processor. So that's all on interfaces. In the next video we'll be talking about encapsulation. Thank you.